Hi girls, so this is the fourth video, and this is dealing with a different area. This is the second area we spoke about, and this is to do with this idea of orbit. Okay, now we have the Earth here. Okay, and there's loads of different satellites that are going around the Earth. And it's called that they're in orbit. Okay, and you have the International Space Station, and there's loads of things that are orbiting, and then the moon is also orbiting. Okay, and there's a key difference that you need to understand between a body or an object or a vehicle or whatever you want to call it that is in orbit and something that is in space. Okay, so if you have a look here, if you have the ground there and we have a rocket here, okay, and you want the rocket to take off. Once you reach a certain point, okay, so you got to go through the atmosphere and all that. Once you reach a certain point, up to say about here, you are said to be in space, okay, but what's going to happen is that you're going to get up to space and then probably run out of fuel and then go back down. Okay, that is not the same as being in orbit. In orbit means that you go around the Earth. Okay, and the thing that you need to understand about this is that you're actually using the gravity of the Earth and the curvature of the Earth to continue to go around the Earth. Now, we said that space was a vacuum. So how they keep the satellites up is really, really cool. Basically what they do is they accelerate off the face of the Earth really quickly. I'll actually go on to a new page here to show you. So if there's the Earth, they accelerate up really, really quickly, but they don't go up in a straight line. Okay, they go up like this, and then they start to curve. Okay, and they continue to curve. So if it's going up like this, and they continue to curve. Then when they get into space, because it is a vacuum, they can actually switch off the engines so that they stop accelerating. Okay? And then what happens is if they're going this way, then what's happening is they're moving parallel to the surface of the Earth. Now if the Earth is a sphere and they're moving parallel to the shape of the Earth, then what's actually happening is that they're continuing around in a circle. And they're going to continue to go around and around in a circle like that. Okay? You can think of it almost if you were standing on a hill like this. Okay? And you had a ball. And you threw the ball. Eventually the ball is going to go and hit the ground. Okay? Because there's going to be, no matter how hard you throw it, it's going to hit the ground. Because there's forces acting on it, just like Newton's first law. There's wind and everything that's pushing it down. But when you get into space, there's no wind or anything, so it's going to continue to move in a certain direction. So if you throw it hard enough, then what's going to happen with the ball is that it's just going to continue on in a certain direction. And because it's moving parallel to the surface of the Earth, it's going to continue on in this motion around like this, and it's going to be in orbit. Okay, now the equation to get something into orbit is this one up here. Okay, so it is, if I go back here, it's VO is equal to the square root of G, which stands for gravity, mass, which is the mass of the object, and r, which is the radius of the object that you're orbiting. In this case, it probably could be the Earth. So this tells you the velocity that you need to get a body to, or a spaceship or whatever. This tells you the velocity that you need to get to in order to use the gravity of the object and the mass of the thing that you're trying to orbit or using to orbit over the radius of the thing that you're orbiting. So this would be the Earth. Okay, so this would be the Earth, this would be the spaceship, this would be the gravity of the Earth, this is a square root. And when you plug in those numbers, so gravity is constant, Okay, so you could just plug that in straight away. The radius of the Earth, we know what that is. The mass of the object, you will know what the mass of the spaceship is. You just plug those in, the square root of that over that, and that will give you the velocity that you need to accelerate the object to in order to get it to orbit the Earth. I think that's pretty cool. Okay, so that is the difference between being in orbit and being in space.